Hi, and welcome to Databases on the Edge. How to distribute your database over hundreds of edge locations. My name is Erwin from Koogh, and I'm a product manager at Cloudflare working on the Workers platform. You can find me at Erwin van der Koogh on Twitter. Feel free to reach out if you have any questions. So, warning, this entire talk is going to be about evolution. But seeing as this is a conference about cloudy things, I guess we're going to be talking about cloud evolution then. Because over the past couple of years, we've seen this trend to see logic move from the region to the edge. And with regions, I mean things like AWS's US East 1. But all major cloud providers like Azure or Google or Alibaba have a similar concept. And when I talk about edge, I mean POPs, or points of presence. They're spread out geographically so that as many customers are as close as possible to a particular POP. One of the most important things they do is cache responses so that your request doesn't have to travel half the internet before you can get a response. So there are some obvious differences between these two, which greatly influences how things evolve on them. Regions have lots of specialized different kinds of servers. They have lots of different products and services running on top of them. And a region consists of multiple data centers, but they are extremely close to one another. Edge, on the other hand, is very different. There's a lot less servers, but they're very uniform. They very much look the same. And that's because there's very fewer products running on these servers. And they're pretty isolated because you want to geographically distribute them all over the world. And of course, there's region's cousin, the multi-region, which is more regions, which means they're spread out geographically. So, let's first look at the history of compute. And yes, before you start, I am fully aware that the following content isn't entirely accurate, but this is my presentation, not my PhD's dissertation. So, it starts out simple enough with mainframe time sharing. And then we get to things like virtual machines, C groups, containers, micro VMs, and then we start to see like the first successful commercial functions as a service. AWS Lambda sort of turns up, quickly followed by Azure functions and Google functions. And finally, we have our first product moving from running into a single region to running in multiple. Lambda at Edge now allows you to run the same function in 13 different AWS regions. But there is this massive chasm here. None of these products have made any progress towards the edge. And there's a good reason for that. And that has to do with the environment, as we've talked about previously. Because a product that has evolved in a region won't be able to thrive on the edge. Which is why, if you want to be successful in there, you have to grow up on the edge. So, what does it look like over in Edge world? We started out with things like reverse proxies and virtual hosts, nothing programmable yet, mostly static configurations. VCL came along, the Varnish configuration language, which allowed people to write much more programmable configurations. But things started to take off properly with V8, which formed the basis of Cloudflare Workers. WebAssembly came along, which quickly adopted for their compute at Edge. And Akamai and Netlify soon followed suit with their JavaScript-based solutions. And we know that this chasm is impossible to cross because when AWS, who already had Lambda and Lambda@Edge working, wanted to run something on the edge, they had to adopt Nginx's and NJS to build CloudFront functions on top of. So let's talk about data. What patterns can we see there? And it starts out pretty similar. We've got relational databases, SQL, which leads to sort of things like MySQL and other databases, and one of the sort of things like RDS, like a managed service. Then there is, of course, NoSQL, because if you have SQL, you need NoSQL, which leads to things like document stores and key value stores. A popular document store is sort of MongoDB, and a popular key value store is DynamoDB. But we also see our first multi-region native database appear, which is Azure's CosmoDB. MongoDB sort of releases MongoDB Atlas, which is their multi-region offering. DynamoDB global tables sort of go to multi-regions. And of course, there's things like GraphQL and sort of FaunaDB that do multi-region as well. But still the exact same chasm. None of these tools have made it all the way to the edge. Why? The first reason is pretty simple, and it's money. Storage is cheap, but it's not hundreds of copies of my entire database cheap. And the next constraint is consensus. It's impossible to create any sort of consensus on the state of an entire database with latency in the 100 plus milliseconds and hundreds of nodes. So, what does growing up at the edge look like for data? And to start there, I want to start with the evolution of Cloudflare. What did it look like for us? So, our first database product was an internal thing. Quicksilver is a key value store that is used as the backend for our control plane. One of the most critical components of our infrastructure, because without it, no updates can be propagated to our edge locations. Quicksilver wasn't affected by the money constraint much, because configuration data is really small, and we only need to store the latest value, not an entire history. And because we have centralized writes, and then fan out any changes to the edge, we didn't have a consensus problem either. The next iteration was Workers KV. Workers KV is a key value store for Cloudflare workers. Money wasn't much of a problem because the full dataset is only stored in a few central locations. At the edge, we only cache recently used entries. And the story with consensus is pretty similar. Not only are the writes centralized, but there's no attempt to create consensus. The last write to arrive at the server wins. Now, many people, myself included, wouldn't call a database with last write wins semantics a proper database. But the truth of the matter is that if you have an application with lots of reads, some writes, and a few updates, KV is a perfectly fine database for your use case. And it turns out a lot of web applications fall in this category. And then we get to durable objects. And this is where things get really interesting. Because durable objects are the new thing in town. They are actor-like objects with attached persistent storage. This sidesteps the money problem by sharding the full data set over multiple clusters. And those clusters are spread out all over the world. A cluster is made up of a small number of close-by nodes, which is also what helps it solve the consensus problem. So how does this all work in practice? One of the most fundamental things to understand about durable objects is that there can be only one. Well, there can be only one durable object per identifier. And if you now have the Princess of the Universe theme from Queen in your head, I'm not sorry. So what this means is that there can only be one durable object available, is we can create durable objects close to where your customers are. So let's show some code examples to make things a bit more concrete. Like, how do we get a durable object? Well, there's two different methods that each have slightly different semantics. The first one is with ID from name, which allows you to create a durable object with an external identifier, such as a username or a company identifier. This will check if a durable object with that name already exists somewhere in the world, even in other clusters. And if it does, it will connect to that existing one, wherever it may be. And if not, it will create a new durable object. The new unique ID will create a durable object with, surprise, surprise, a unique identifier. The most important thing here is that it creates that object as close as possible to your user. Everything is the same except for these two methods. Also note that the only way to invoke a durable object is to go through a regular worker. So the code you see here is a worker that gets a counter durable object. It calls the fetch method on it and awaits a response. So the next bit about initializing a durable object. Now, a durable object is just a class. Initializing can be a bit tricky because it's possible to have multiple requests coming in at the same time. But if you follow this template, everything will work out just fine. We have a constructor and an initialization promise that we store on the class and that we await before we proceed with any processing of requests. In the case of errors, it will handle the error properly and retry initialization. And then in the rest of the fetch method, you can do whatever you want with both instance variables and persistent storage. You don't have to use either of those. In the example here, we increase the current value if the path name of the URL is /increment, and we store that before returning the current value to the worker, which can transform that again if it so desires. And durable object has full transactional support, a real proper database. For example, if you want to create a lookup table, which can look up a name and a Twitter handle, or a Twitter handle and a name, you can do these two puts in a row inside a transaction. And either both of those will succeed, or both of those will fail. This leads us to an important question. Like, what would you use durable objects for? And there's a lot of different things. You can do things like per user caching. Right? Create a new durable object with a new ID, and it gets initialized close to the user, and they can now query that for a set of caches for just them. Maybe you want to create a queue to do offline processing of things. You can do event streaming. Durable objects can receive and initiate WebSockets. So you can create a WebSocket, a user can create a WebSocket to a durable object, and then the durable object can stream events to the user. Or you can take that one further and do things like collaborative editing, where you have one durable object per document and multiple people have a WebSocket connection open to the durable object. Another thing is going to be a lot of interesting going forward, where a lot of regulation is coming into place, where certain governments or large organizations have to store their data in a particular region. And what we now have to do is we have to spin up copies of our applications in all these different regions to support data in different regions. But a durable object, you can specify a jurisdiction in which you want to store that durable object and its associated data. So you can guarantee that a user's data, for example, never leaves the EU. And a much fun one is multiplayer game. Last week, we released the original Doom multiplayer on durable objects. But more importantly, we haven't begun to scratch the surface of what's possible with this region global. And this is just our journey, our evolution, and our model. It's quite possible that different people will come up with different ideas on how to store data at the edge. And that has me so extremely excited. Because data on the edge is just in its infancy. And I, for one, can't wait to see where this will take us. Thank you very much.
Erwin, thank you so much for the great presentation and for the great introduction.
Yes, no worries.
Yeah,
sorry, I'm sort of typing my one last thing. All persistent storage. There we go.
Oh, okay, great. Yeah, we're happy. So yeah, thanks a lot for the great introduction and for introducing running the database at the edge. I'm extremely excited about seeing what's next, and obviously what you do at Cloudflare is extremely interesting. And finding more applications, some of the use cases that you've outlined are quite fascinating. We have about 20 minutes for the Q&A. I'm seeing a lot of good questions popping up in the chat for the attendees. Yep. Please keep them coming. So yeah, probably, Erwin, to start with that, you mentioned that you want to store durable objects close to the users and ultimately to workers that process data and send them to the users. Today at Cloudflare, how do you decide where to place the durable objects on? Because I assume that you run with many points of presence, many locations.
Yes, of course. Yeah. So like the first thing is we don't run in data, durable objects don't run in every sort of location because we've got everything from small, like a one rec in sort of an ISP to sort of our own sort of data centers. But yeah, so there's clusters are sort of like a handful, 4 or 5 sort of colos that are sort of close together. And so if you're sort of, for example, a user sort of connects to a sort of a worker, and they're looking for to create a durable object. That durable object will be created in that sort of colo, in that sort of data center. And if they don't, Like if they're in a, like, it'll just go to the nearest sort of colo that has durable object support.
And the follow-up question to that, how do you have some sort of a control plane, or do you use something like DNS to actually connect the request to user with a specific server? Like what's driving the routing of those requests?
Yeah, great question. So what we have is sort of yes and no. So basically how it works is when you request, so there's the two methods to create a durable object, right? Like the easy one is to, when you go, give me a new durable object with a new unique identifier, right? In that case, we don't need to do sort of much. Like the colo itself can generate that ID because the colo ID is part of that sort of identifier. So nothing needs to be done. So it's the owner of that, like it specifically is the owner of that durable object, and sort of the rest of its cluster is sort of the backup for that durable object in the case of sort of any outages. So that doesn't necessarily require like a lot of a control plane. What is slightly different is that if you have an external identifier or sort of anything else, like if you do the from name, what we need to do is we need to check whether that is where, if there's any copy running already, right? Because we mentioned that there can only be one durable object instantiated at any time. So that goes through sort of the control plane to sort of get consensus on sort of if there is a durable object with that particular identifier. And if there is, it will get back the identifier and sort of connect to the sort of the correct sort of data center to talk to that durable object. And if there isn't, it will generate an ID. And that ID will be cached by every data center. Okay. So that for future reference, like they don't need to go to this sort of central repository. So that's sort of how sort of the sort of control plane works. And so looking at an ID, everyone can figure out where to talk to. Like you first try the data center that it's running in, that it's supposed to be running in. And if not, there's fallbacks to other machines in the same cluster.
Okay, great. Yeah, thanks a lot for detailing that. There are a few great questions in the chat.
Yeah.
So first question is from Aaron. What do you do when there are network splits or when you lose the segment of your network? What would be the resolution for you to recover from that?
So the data center that the durable object is running in is also the sort of master of the persistent storage, and the rest of the cluster is used to sort of replicate the data. So networks and sort of like there's like network splits between clusters are fine, sort of right, because that's because there's nothing shared between sort of different clusters. So within the cluster, it's also highly unlikely that something like, again, if you get like the correct network split, I'm not entirely sure what happens, but I think one of his other questions was like, do we use any like database technology? And the thing that we use to store the data and run the clusters is CockroachDB. So I'm not 100% sure sort of how exactly those were configured, but but yeah, like network splits are very unlikely to. Look, I'm not going to say impossible because it's probably not impossible, but very unlikely.
What about the fire in the single pop in the data center?
So fire in a single pop is definitely something to survive. So like if the sort of heartbeat of a durable object sort of stops, the rest of the cluster will sort of take ownership of the durable objects. And again, that's sort of where the fallback sort of comes in place.
And in that case, your replication strategy is trying to minimize the risk of losing multiple data centers at once, at which point it becomes almost impossible event. Yeah, got it.
Yeah. I certainly and again, like the difference between that sort of region versus like the edge, like in a region, all your data centers are like pretty close to one another, right? Like they're like kilometers or tens of kilometers at most away from each other, and we don't have that, right? We don't have, we may have 2, at most 3 data centers in one city. So our nodes are spread out, sort of by definition, basically.
Mm-hmm. Got it. Great. Yeah. Then there is another question from Gaurav. What's the ideal size for the durable objects? Do you have any recommendations or generally the range of what's supported?
Yeah. So like the fun thing about durable objects is they're great without persistent storage. Like just using it as a method of coordination. One of the things we built for the company, the startup that I ran before being acquired by Cloudflare, we just built log streaming, and we were streaming data, and so we were streaming data to 0 to n sort of participants, and a durable object was perfect for that, because the builder would just stream the build logs to a durable object, and if anyone was interested in it, they would connect to the durable object and sort of start streaming the events. And because like it was a durable object with like we only used in-state memory for storing the build log up to that point. So yeah, like that was sort of stuff that was sort of really, really useful. So like you don't even need to use storage. And if you do, like I'm not aware of any sort of upper limits. But like I can't imagine, like it'll be hundreds of megabytes, gigabytes of data. Like it will be fine.
Yeah.
So yeah,
great.
I wouldn't worry about it.
Okay. Yeah. Cool. Thank you. Then another question from Floran on the semantics. Like you call them objects. Why are they called objects, not documents? Like, is there some sort of object-oriented style of how they're going to be used to design for the APIs, or is there another reason?
So there's this, like, and this was before I joined Cloudflare, so I can only sort of talk about sort of what I heard about. But there was a big sort of back and forth between, do we call them durable actors or durable objects? Because they sort of have a bit for sort of both. But yeah, like they definitely have that that encapsulation of behavior, because it's just JavaScript that you do in your fetch, and you have your sort of persistent data. So it's definitely sort of fits that sort of object in traditional sort of object-oriented sort of model.
Yeah, great, thank you. Then another interesting question from Jandrik. How do you manage access to the durable objects? Do you have any sort of access control, and how do you manage permissions if you do?
That's a great question. So like the worker has one or more workers, because it's not limited to sort of one worker, but like there's always, so you need to have a worker in front of your durable object. And that's where you would do your sort of access management. Most likely. Or you can just pass that information sort of through to the durable object for the durable object sort of to do it. But yeah, like there's no inbuilt sort of permissions or sort of access control. you have to do that either in the worker itself, or you just forward the HTTP request to the durable object and then they do it.
I see. Okay, great. That sounds like it works. So another question from Tidar: if you detect a remote durable object, so you don't have anything stored locally on the node that processes the request. How do you do you then fetch and materialize it locally, or just kind of pass the information remotely? How do you kind of manage the storing and managing the location of that object?
Yeah. So again, there will only be one, right? So we will never move a durable object away from its data. So if there's a remote sort of durable object, we will connect to that remote durable object, and it's a request response, right? So it's modeled like even modeled like an HTTP response, even though it isn't technically HTTP. That they talk, but yeah, you basically make an HTTP request to a remote durable object wherever it is in the world. So yeah, there's no, because once and that's sort of why it works so well, because you have your in-memory state is always going to be the same, right? You can't just, if we would instantiate it locally, you now would have multiple copies and your state would be ruined.
But in that case, if users moved, do you have any sort of data migration mechanism?
Let's say,
so the object was created when user was, let's say, in the US, but then the user moved to Europe. Will they have to keep talking to the US, so you have some sort of mechanism to move that while keeping this single copy concept?
So right now, you'd still be talking to the location, but it's definitely sort of one of the things that the team is sort of working on. It's on a roadmap. Like how do you automatically migrate durable objects? Because it's not just if the user moves. It's also if you have two things that connect to a durable object frequently, right? Like there's the US and there's sort of Asia. There could be possibility to go maybe it'd be better if we move this thing to Europe because it's closer to both, right? So there's a bunch of scenarios where we could do automatic migrations of your durable objects, and there's definitely sort of the groundwork is there, but yeah, it's still not. It hasn't finished yet. But it's definitely one of the things we're really excited about. That below this abstraction layer, there's a lot of potential for sort of optimizations.
Is it similar that you're looking into some of those optimizations when you have the same user accessing from two different devices or potentially on two different networks? Would it fall into the same category of optimizations, or there are more nuances?
Yeah, no, it's the same thing. It's just how do you move the durable object to the place where it's the most optimal. Yeah. But yeah, that's not just to be sure, it's not in the product right now.
Makes sense. Well, I think as you mentioned, this is a relatively young product, and there are plenty of ways to have applications to find the users and the proper optimizations for that.
Oh, absolutely, yeah.
So the interesting question from Chris: durable objects as you presented it. It makes sense if you run your code on the edge or maybe on the client side. But what if you run the code in the data centers? In the introduction, you mentioned that this is kind of the previous architecture, how we've been running the code in the region or the multi-region. But how can one benefit from durable objects if your code is still in the data center? It's still in a full region, not at the top.
Yeah. So this isn't an all or nothing sort of thing. It's that sort of, and again, the build streaming sort of example that sort of we had, that was one of those things where the rest of the application was running perfectly fine in US East 1. But we picked out the durable objects for just the build log streaming. But it's definitely aimed, like you get by far the most benefit out of it. Like if you move to what we Cloudflare call region global, right? Like region Earth, like that's because I'm like that's sort of where, like how we're thinking, and this is the sort of one of the foundations that we are building, for that region Earth sort of thing where there is no US or EU or APAC or like, no, you've just got data, and we'll figure out where to store that data depending on the constraints that you've set, right? So you can just go, I want, and that's the thing I sort of hinted about. Like you can, for example, you can set jurisdictions for individual DOs, right, for durable objects. So I can go, Sergey is in sort of the EU, so his data is going to be stored in the EU, whereas sort of I'm in Australia, so my data is going to be stored in a sort of Australian data center. And it's those sort of kinds of sort of like things where it starts to become really powerful.
All right, I think we are running close to the end of the 40-minute slot, so we probably have a time for one more question. And there is a question from Powell about leveraging some of the legacy systems that do ID management. Like imagine if you have a legacy control system that does manage the IDs for you, how would you be able to introduce the durable object concept by integrating that to the control plane that already exists?
So if you have a global ID in your external system, and you want to sort of use those IDs in durable object, so I'm not sure if those legacy systems need to be part of the control plane, because sort of like if a durable object, for example, can just sort of itself check sort of if you like, I assume that you may or may not want to sort of have a durable object for things that either are in your legacy system or aren't yet in your legacy system. And durable objects, again, because it's just JavaScript, they could check if something is or isn't sort of in there, and sort of depending. And like I don't think there's any plans to like allow external parties to integrate with the control plane, but I haven't heard of it, so I don't know. Maybe it is.
It makes sense. So yeah, Erwin, I think we're at the time, and thanks again for giving the presentation, for answering the questions. Awesome. We have 20 more minutes in the Hangout room, which is going to be more informal. There are a few questions that might be benefit from a little bit more informal chat, so I'll welcome the attendees to join, and both Erwin and I will be there. And there are also a couple questions about more links and books, introduction to the databases. I think we'll leverage Slack channel to post those materials for the attendees. Thanks again, everyone, and see you in the Zoom room or see you in the future sessions on this track.